Right, I'm going to be talking today, first thing we talk about is switching techniques. How do computers transfer data from one machine to the next machine to the next until eventually it gets to the final destination? That's known as switching techniques. There are two main techniques that are used in computer networks today. But I'm going to talk about a technique that is no longer in use today. But it's good to know about it from a development point of view. And the first technique is known as the message switching technique. Message switching technique. And this is real old. It was used back in the 60s, almost at the very start of computer communications. And the way it worked is that if you have a message or a file or a report, put it into the computer and transmit it to the nearest computer. And because it's so big, it has to be saved onto an auxiliary storage device. Computer has two parts of memory or storage. One we call the main storage device or main memory, and that's extremely fast. It operates at electronic speed. And the other one is the auxiliary storage device or secondary storage device, which is a hard disk or a CD or a tape. Excuse me. And back in the 60s, there were no CDs or there were no DVDs and no CDs. Maybe hard disks haven't even appeared, so they used to have those tapes. So they used to have a cassette or big reels of tapes where this file is stored onto it, copied, fully written. And then once it's fully written here onto this computer, then it connects with the next computer and starts transmitting it to the next computer, and so on. So it keeps doing it until eventually it gets to the final machine, and here's the file. Now, because tapes are so slow, it takes a long time to copy the stuff onto tapes. And maybe for a big file, it could take 20 minutes or half an hour or even longer to actually write the data. And if you have to pass it over a number of machines, it can take hours to transmit a file or a message. So that's what's known as the message switching technique. So it's extremely slow because it actually depended on this tape that we have to store information onto tapes. The other problem with it, while you're transmitting, and while it might take 20 minutes or 30 minutes, if it takes 30 minutes and at minute number 29, an error occurred here, we'll say, okay, stop, start again. And you could end up having a lot more delays if there are any errors. So, as you can see, that was the form of communication then, but there was no alternative. So, what developed from that, back in the 70s, but even later in the 90s, was the datagram switching technique. The next technique that came out, and it's known as the datagram switching technique. And the datagram, just from the word datagram, as there used to be telegrams and smaller units, they call this a datagram. So it's almost the same technique, except they placed a limit on the size of the message. So if you want to send a big file like that, first break that file into smaller units. And we call each one of these a datagram or a packet. And now we can send those. So, for example, if we had a network like that with these devices here, we call them routers or switches or whatever now, that we could just call it a network device at this stage. So the technique says if you have a message to send, break it into smaller units, we call them datagrams. Each gram, put the address on it, source address and destination address, you need that. And what's even more important also is put a sequence number on top of each one. So each one of these will have where is it coming from, where is it going to, and a sequence number. So it'll be number 1, 2, 3, 4. and hand them over to the nearest machine. So everybody's connected to some device that connects you to the network. And that takes, each packet receives the first packet, and it has to decide the best route for that packet individually and separately. So it looks at the first packet, it looks at where is it going, says, okay, based on that, is it better to send it that way or this way? In this case, there are two options, so it might decide to send it in this direction, and it sends packet number 1 that way, or datagram number 1. And this is reached at this machine that can also look at it and say, all right, this is the best way to go, and there it is. Here's the final destination. And after sending few packets, you might end up, this router here or this device might say, this line is getting slow. I have a faster line this way. I might send number 3 and packet number 4 and so on this way, so some of them. And as they get here, number 3 could end up going in that direction. But if this is a really slow line, this device might say, hey, number 4, it's better off if it goes this way. And it sends packet number 4. So as you can see now, instead of one big message, now we have, you could even break into 1,000 packets or even 1,000,000 packets. And number them, give them sequence numbers, and just hand them over to the nearest device, your gateway into the network, and it will take care of it. It will send them onto the best line. If this line becomes slow, it will probably send them into a different direction, and every router will check that address and finds out where is the best location, where is the best route for that packet. And they'll all flow. Eventually, they'll all get here, and the final machine, after receiving all the packets, and it can see the sequence numbers. If they're out of sequence, it will put them in the proper sequence, because here, remember, some packets might get late, delayed, going in some direction. So if we're sending 1, 2, and 3 here this way, and then this line got jammed, we switch to the next line. So number 3, 4, and 5, they could end up getting before number 1 and 2. So there's a possibility that we might get those packets out of sequence. So at the end, we have to put them back into proper sequence, remove those headers that were added, and make up our file and hand it to our customer at the end. And if you are to think of this system, always think of the postal system, the ordinary post, not the registered post. If you are to send a letter to Spain or maybe to India, one letter every day, the way things work at the postal system, they might look at the first letter today. They get a letter today, it's after being posted for India. The postal office will look at the letter and say, okay, this is for India. We don't have direct connection with India. Let's say that's India, this is Ireland. We don't have a straight flight, but we have a flight to London. So we'll put this onto London flight. So it goes to London flight. Tomorrow's letter might go into London flight. The next day, maybe there's no flight to London. Or maybe London, there's a strike or something. But we can put it on a flight to Rome. It will still get there. So we'll put it on a different flight. So if there is anything wrong with this route, we can switch to another route. And the postal system, they never look at this letter and they say, oh, this belongs to the same guy sent a letter yesterday. There is no relationship within this system between this packet number 1 and 2 and 3 and 4. They don't care. They treat each and every one of those packets or letters independently. Each one is fully independent, has its source address and destination address, and that's what they're interested in. And the same with the postal letter. When you send a letter to somebody, there is an address on it. That's all they're interested in. They're not interested in the other letter that you sent yesterday or tomorrow. That might be more important to the final destination. The point is, if you send few letters through London, from London it might be put onto another flight to Rome, from Rome it might be put on a flight to Dubai, and then from Dubai to Delhi. Another letter that you send the next day, it might go to London, Madrid, Istanbul, Delhi. So it doesn't matter. There's the network. That's the network. And the postal system or the delivery system here will always try and find the best route. And the same letters going from one source to the same destination, they might actually follow different routes at different times. And that's how computer communication works using the datagram switching techniques. So as you can see, It's a fantastic development. It's a huge development from the message switching technique to the datagram switching technique. You can actually send a message from here to Australia in 1/1,000,000th of a second. That's how fast it is as compared to the minutes or hours it used to take to send a message from one location to the next. So that's the tremendous improvement in speed in communication. The reason why this jump in speed in delivering data is that we no longer use hard disks or tapes to store a message at each computer. Everything happens in main memory of computer. So as long as the message fits into the main memory, it will just fly through. Main memory uses speed of electrons, which are possibly about 2/3 the speed of light. So they're extremely fast. Things can go around the globe in less than a thousandth of a second. And the internet nowadays is based on this datagram switching technique. It uses this technique for transferring data. Any message you write from your machine, whether it's an email or you're uploading a picture or a file or whatever it is, it's broken into small data units. We call them datagrams or packets. Each one of those is given a sequence number. It's given a source address, the address of your machine, and the address of the destination machine, plus a lot of other pieces of information. So we'll get to know them as we get to know the communication system. But for now, that's the minimum pieces of information required in a datagram as far as we are concerned. And then that message is broken into datagrams and given out to the nearest machine, and it goes around until it reaches the final destination, where it's reassembled again and given to the final destination, the person or entity or machine you're sending it to.
Sorry.
Yeah.
Is the datagram contains acknowledgement received or sent?
No.
Packets or...
This datagram does not, the datagram technique, the basic datagram technique, does not provide acknowledgement. So when you send a message, you don't know whether it got there or it didn't get there. You don't get told. And if you send a message and during transmission there's some noise or there's some interruption or a problem that changes the content of that message, there's no error detection. So you're not really sure whether it got there as you sent it or not. Pretty much like the postal system. If you send a letter to somebody in India or Australia, I'm talking about the ordinary post, the letter goes there, and you don't know whether they actually received the letter or not. There's no confirmation. You might write the wrong address, and instead of the address 14, you write 1400, and there's no house number 1400. And most likely, you don't get that letter back, or you don't get told that the letter is not delivered. So that's how the datagram switching technique operates. And you need to remember those features. That the main feature in it is that there is the limit on the maximum size you can send. Any message has to be broken to smaller units. Every message must carry the full information it needs to be routed around the world. That's the source address and destination address. There's no confirmation of delivery. There's no confirmation if it's lost. There's no error detection. What's more than that, if many other people use this link or this part of the network, for example, other people are sending or other entities or users are downloading files, too many people or too much traffic goes onto the network, guess what? It's going to start slowing down this network. Every router, every channel has a capacity, has a capability, has a speed. So if you go beyond that capability or capacity or a speed or power, then you're going to start suffering, and you can see that from performance. Things go slow. So that's also another feature of datagram switching technique. So you probably have watched a video streaming down, maybe to your computer, and then every now and again it slows down, stops. The network is not fast enough to deliver the required speed for a video. Video takes a lot of it has a lot of data and it needs to be flowing relatively fast. So datagram technique may not be the best way to watch a video if you're downstreaming a video. But it has other good points as well, because there's no limit on the number of users. Anybody can use it. You never get blocked. The network never says no to you. If you have data to send, all you have to do, chop it up in pieces and send it out. That's a good thing, that you are never blocked from one end, from one point. Another point of view, if you say nobody is ever blocked, that means number of users can always get very high at any time, and that makes things really slow. So from another point of view, it's not really great. The fact that there's no control over who can send data or how much data. So that's known as the datagram switching technique, and that's one of the techniques that are used today. Look at another technique that's also used today on higher speed networks. There are other networks that are high speed, kind of the highways of data communication. And they use slightly different technique. To talk about that technique, I'm going to talk about, again, an older technique first, and that's called the circuit switching. So circuit switching is an old technique, just like the message switching technique that's no longer in use today. Circuit switching is the technique that was used on telephones, the old phone systems. And the way the old phone systems work is that in every road or every street there is a switching box. There is a box they call the switching box. And all the houses in that street, they have phones and they're all connected to that switching box. So all the phones are in the neighborhood are connected to the same box. And on every street there is another box. And the city is just full of those boxes. So this box is connected to that and that and that, and then this box is connected to a few more boxes, and so on. And maybe eventually, at the other end, I'll go to the other end here. There are phones, again, on this box. All the neighbors are connected to the same phone here. So that's the old switching system used in telephone systems. In this system, if you want to call somebody, you pick up the set here, the handset of the phone, and if you want to send data, you can't just, like the datagram, take your data and hand it over to the nearest machine. Now, there's a step you must do before that, and that's known as the call setup. You must do something called call setup. Before you can send data, you must pass through this phase of setting up a call. And it could be a successful setup or a failure, and if it doesn't work, well, then you can't send your data. So the phone starts by, actually, the circuit switching starts by the guy here dials the number. And in the old days, we used to use this circuit switching technique. We used to use the network, the old telephone network. You're given a modem at home, and you stick the modem between, your phone line and your computer. And that modem, you can dial another computer, another number. But this is the way it works. You start dialing the number, and the signal goes to the nearest switch. And that switch is actually a switch that rotates around. And there are lots of switches, one on top of the other, in disks. And the more switches, obviously, the more possibilities you can call. But this switch now can either connect you to that line, or that. Let's assume it turned into this direction. So now you're connected to this box. And this box is possibly, based on the next number, it also has a switch. So it can be rotating around. And let's say it connects you to this line here, to this box. So there's a switch here that makes the connection. So now we have a connection as far as this box. And then from this box, we might be connected to this box again. And this box here is connected to this phone. There's a switch here that rotates until it lines up those two wires. And you end up having one electric circuit from here. And that's where possibly the name came from, circuit switching. That you have one circuit all the way from this phone all the way to that phone. And once the connection is made, the phone starts ringing. Once it rings, hopefully somebody will lift up the handset, and that will be the call setup is done. Now we can talk. Now we can send data. So that's how circuit switching works. First, you must set up this call, and if it is set up, then now we can start sending data transfer. So if it's a modem computer, we can start downloading our data. And if it's not a computer, if somebody talking, now you can talk. And the other guy can listen and you can communicate. It's called the data transfer phase. And when you finish communicating, you must clear up the call. And we call it call clear. And what does the call clear do? It leaves this. It puts all the switches back to neutral position. And now we can use this line. Someone else can use this line. This circuit, one of the features of this circuit, that when you get a call set up, this circuit is dedicated to you, only to one call. It's not shareable. If you notice here in the datagram, you can be sending your packets, your message this way, and someone else can be sending the message. And the packets, they don't all belong to you. Packet number 1 and 2 belong to you, but maybe there's another packet number 77 and 83, they belong to another user that's going to be sent along the same line. So all these lines are shared, and that's a very important feature of the datagram. All the links on it are shared. Right through the call. Here, it's the word dedicated is more. So once you get connected, if someone else tries to use this link, they'll get a busy line. They can't set up their call. That's why sometimes in some villages, where there's a village beside a big city, and if we have a telephone line connected to it, and if you make one call, that's it. So another one wants to contact someone else in the village, they'll get a busy line until the first one finishes, because that line is dedicated line to the caller. Okay, eventually they came up, we'll talk about multiplexing, where you can maybe merge a few calls onto the same line. But I'm talking about the basic technique. The basic technique is a dedicated line. If we can share it, maybe make it dedicated to 10 people, that's different. But the basic technique is dedicated line. So just comparing this old circuit technique with the datagram switching technique, there's a huge difference. On this one here, on the datagram switching technique, on this line, we can have 10,000 calls simultaneously happening. You can download, and someone else is sending an email, and someone else is just maybe looking at some library, uploading a file or something, or an image, but 10,000 people can be using that line at the same time, while here, one person per line. So just looking at it, this one would not be a great way to use the links. It's not, from utilization point of view, is low. Utilizing the links or the channel is very poor. This one has a very high utilization of the channel. You can have 10,000 people using one channel, one cable, while here, one cable, one user. It's not great. And it's also, of course, it's going to be more expensive. So if you are a network, if you are a businessman and you want to set up a network, would you set up a circuit switching network or a datagram switching network? Of course, you're going to get more users out of this one who will pay less, and you'll still make a lot more money, rather than having a circuit switching technique that there'll be very few callers at any given moment. So this is much cheaper because the links on it are shared. But the telephone companies, they say it's easier to manage. It's easier to know who is making the call. Accounting is easier. We know who made the call. Why? Because you must make a call. You must request a call. So, okay, we're going to charge whoever makes the call. In datagram switching technique, there are no calls. The line is always there. Anybody who has data can send it. You don't know who is downloading and who is uploading. That's why they don't charge you normally by the call you make or the data packet. They say, listen, we give you a line, it's €20 a month. How's that? And that's fine, because they don't have to manage anymore. They get rid of that all software. But it's not fair. You may not use the line at all for a month, but you still have to pay for it. Now, the old telephone companies used that. And as they started seeing that the computer is becoming to be a major communication competitor, they didn't want the money to go to computer companies. So they said, we are so experienced in communication, and we better come up with a solution. And they did come up with a solution, and that's an improvement of this circuit switching. But of course, because it's a circuit, this one, they say we'll try and use what might look like a circuit, but instead they called it the virtual circuit. The virtual circuit switching technique. And the virtual circuit switching technique, the way it works, it uses almost same devices here, same routers, say almost. They call them switches again. They keep the old names for the telephone company, but it doesn't matter to us whether this is called, at this stage, a router or a network device or a switch. As long as you know it's one of the network devices which will route some of the information or connect some of the computers together. So the point here, they say, and just while we're talking from now on, we'll always have devices in the center, and we intend with those are the network, and the users are always kind of outside the network. It's like the neighbors here are connected to the internet. Every group of them are connected to one network provider or one gateway to a network. So these are always kind of the users on the outside. Whenever we draw a network on any of our textbooks, we'll have the subnetwork or the main part of the network or the infrastructure of the network in the center, and around it are the users or clients of the network. So the virtual circuit switching technique, the way it works, is pretty much, it's quite close to this one, but they say you must first do a call setup. You still have the same phases, but now it's not a mechanical phase, it's electronic, it's program, software, connectivity. So you must first send a request, and the request is just like a small packet, small datagram. And if you want to connect with somebody else, somewhere else, you also need to identify that person or that device or machine or software. And that's through a source address and destination address, and this is a request for a call. Very small packet, but it must contain the full address of the source and destination. And that's given to the nearest device that we have, your gateway. So this gateway here will say, right, I know who you want to communicate with, who you are, and I can send you either that way or this way, whichever one thinks it's at that moment of time is the fastest route. And it will mark it in its table. It has a table of about 10,000 lines or 10,000 entries, and says it'll look for a free entry. Let's say they're all busy. There's one here free. So I'll tell you, yes, your line number 77. I know A, this guy is A, wants to communicate with B. A and B are addresses here. So it keeps information about that particular call. A is requesting a call to communicate with B, and I received A on line number, say 1, 2, 3, 4, or line number 4, and I'm going to send it on line number 7. So just have the lines where it receives the call from, where is it going to go. And forwards the request to this device. This device also has this, what we call virtual channel tables. And it looks for another free place, finds where's the best way to send it, this way or that way, and let's say decides that way is the fastest. And from this machine, 1, 2, 3, 4, 5, 6, so it says I received a message on my line number 6, request, and I'm going to forward it to 4, and that's A communicating with B. It's still a request. So it's forwarded here, and this is eventually it's forwarded to this guy here. And this one has to accept it. And once he accepts it, or she accepts it, or the device accepts it, it will be sent back along the same route, following based on those tables to this one, and now the call setup is done. Only in the first message, you put your full address, source and destination addresses, and that's in order to book all the routes right through. But after that, you take the message, break it into smaller packets again, And you don't have to put the source or destination address anymore. All you have to put is that booking code, which here we call the virtual circuit or the virtual circuit number. So you just write 77 on these. So as you can see here, the header is reduced a lot in this system. And therefore, this is more efficient at carrying data. If the channel can deliver 1 million bits per second, most of those 1 million bits are going to be user data, not redundant data. Redundant data is data that's not sent by the sender. It's been generated by the system, and it's cost the system. Yeah?
You will keep putting this up on the
I will, yeah.
No, I'm busy writing stuff down. I'm not actually hearing you. So.
Don't write stuff down. Listen to me. Understand it so you can talk about it. If you can talk about it, you'll be able to write it. I'll have some of this material on Moodle and the notes on Moodle, yeah?
Basically, the virtual
Circuit.
channel, no, virtual channel table. Am I right? The virtual channel table.
Yeah.
Contain list of routes.
List of phone calls or communications that are happening at the moment, as far as this one is concerned. It knows who is talking to. Anytime a call starts, it just writes it in the table. It says, A is communicating with B now. And it just writes those port numbers here. So it knows it comes from this line, it will forward it to that line. That's all. For this call, for this device here, it just has a list of all the calls at the moment. Okay, just to make this easier, as we said, this one is similar to the postal system. This one is similar to booking a holiday, booking a flight, right? Think of going for a holiday. Right, just imagine, you're here and you want to go again to Istanbul for your holiday. So what you do, you probably book a flight from here to London on Aer Lingus. So that's the one that will book it for you. So here you'll be given, we know eventually you're leaving Dublin going to Istanbul, but right now you'll be going to London. And we give you this booking code. This booking code is like this virtual number. And then you haven't traveled, but you'll book flight from London to Paris on British Airways. And that's where British Airways now, they'll write your details, they know who you are, where you come from, where you want to go, and this is your booking code. They give you some booking code. And then you'll go and book something on Air France, maybe from Paris to Istanbul. And they'll also give you another booking code. So if you've got all the bookings, you'll receive the confirmation here. Now, we say your circuit has been established. But in the old days, we used to say circuit. Now, it's a virtual circuit. And what's the difference now between a circuit and a virtual circuit? In the past, the circuit is connected and it's dedicated to you. No one else can use it. But of course, now, as you know, we can't have all the flights booked for you. The flights are flowing. Everybody is using them. The same routes that you booked are being used every day by many people, shared. But you have a booking. That's what the virtual circuit is. Whenever the time comes, the date, you go to the airport, all you have to do is show them that code number. They say, oh, we know who you are. We know where you're going at the end. But right now, go to gate number 15, and you'll be in London. You get to London, and it's the same thing. You go to British Airways. They can get you a record. They know where you are. They can also direct you to this gate here. This gate is like the connection in the computer, line number 5 or 6. And eventually you will get there. And that's what we call a virtual circuit. It's like you book flights. You have confirmation. If you go, you'll get onto the flight. But if you don't go, flights are being used by many other people. So it's shared. So now this channel, we got rid of that dedication bit. Those telephone companies, they came up with this idea that now these channels are shared. But the good point about it, you have confirmed booking. Whenever you want to go, whenever you have data, we'll take it and we'll deliver it. Now, if, for example, the capability of this device or the channel is 10,000 calls, then they have on their table here 10,000 records. Anybody who wants to make a phone call or communication, they look for a free one, and once they allocate it to you or they give you a booking, they put a B on it, says busy, busy. So if the 10,000 calls are there, Number 10,001 comes up to request a call. They say, sorry, we can't take you. We are full. Right? So if we forward your request to this router, but this router says, I'm too busy, then this one will probably direct it to another router. We'll get you there, but not through that router. Is that good or bad? There is a possibility that you might get blocked during the booking, the initial booking of the flight or the call. But they do that. They could block new communication in order to provide and maintain a minimum quality of service to existing calls. So these guys here in the virtual circuit, the new telephone companies, they say we can guarantee a minimum level of service. We can guarantee you when you watch your video, you will not be interrupted. And they say we will be better than the datagram switching technique. Because maybe 10, 20 years ago, all people were looking for, just give us a connection. It doesn't matter how good or bad it is. You get the internet at home. But 10, 20 years from now, they're not going to be satisfied with just a connection. They want a connection with a good quality. And that's what virtual circuit switching technique claim they will provide. And they do provide. They are the fastest networks around the world. And it's based on this virtual circuit technique. So these are the two major techniques we have around the world today. And they're both in use. But this one, the datagram switching technique, this is the one that's used by the internet. It's more geared towards the user, the end user, the house, down as far as the house. It's cheaper. The lines on it are shared, so are these lines are shared. There's no blocking on this one. You're never blocked, you're never refused. But because of that, too many people sometimes use it, and at some certain occasions, there's too much traffic happening, and things slow, and sometimes they grind to a halt. While this one, that always guarantees like a minimum level of service. So these are the major switching techniques.